first thing you need to do is take your test tube. Okay, here's the test tube, and we need to get the mass of the test tube. So we're going to put it on the balance. Wait till it zeros. And there's the mass of my test tube, okay, 8.76 grams. So I'm going to write that down where it says mass of test tube. Okay, 8.76 grams, mass of test tube. Next thing I'm going to do is get the mass of the Cu2CO3OH2, exactly 1 gram of that. So to measure exactly 1 gram, first I'm going to put my weigh boat on the scale, and then I'm going to hit the 0 button. Okay, and then I'm going to add 1 gram of this substance, and I'm going to do it slowly. Okay, I'm going to hit the 0 button again, so it says 0.0 grams. And you can see it's kind of a greenish solid, so I'm going to add it slowly, so that way I get exactly 1 gram. I'm using a spatula. Getting close now. I'm going to add it slower. Alright, so I've got, well, it says 1.01. So it's not exactly 1 gram, but this is what it looks like. So I'm going to write down in my data table that I have 1.01 grams. That is what I'm starting with. Okay, 1.01. Next thing I'm going to do is I'm going to add that 1.01 grams to my test tube. So what I'm going to do is bend my weigh boat and add it to my test tube. Trying to get it all in there. You can see there's still a little bit of green left over, so I'm going to use my spatula to scrape out the rest and get it all in there. Alright, so now I've got this green solid, and the next thing I'm going to do is use my test tube clamp and my Bunsen burner, and I am going to heat it up until it turns into a black solid. I'm back. So now I'm going to turn on my gas. Here's my Bunsen burner right here. Okay, got the gas on. You can hear it. I'm going to light it with my striker. Okay. And then I'm going to use my test tube clamp, and I'm going to heat this up. It's going to be green, and I'm going to heat it up until it turns into a black powder. And I'm holding it at an angle so that way I don't get any of the test tube clamp into my hand, because I don't want any of the heat transferred, because that would be hot and I don't want to burn my hands. And I'm going to get all the green off the side. So you can see it's starting to turn black. If you look at the chemical reaction, you can see some of what it's going to do is it's going to produce some gas. Carbon dioxide gas is one of the products. Another one of the products is liquid water. So it sort of at first looks like a liquid, which is what it kind of looks like right now. It kind of looks liquidy. You can still see there's some green there, so it's definitely not done. And you can see it's kind of liquidy as I shake it. So I have to continue to heat it until it's all a black powder. So it's going to take a little while. So what we're going to do after this is we're going to figure out exactly how much. I'm going to cool this down, and then we're going to figure exactly how much copper oxide, which is the black powder, we should get in this lab. When I started with my 1 gram, I started with 1.01 grams, but So it's still kind of getting rid of that water. I can see there's still some liquid in there because it's still sort of jumping around a little bit. When I shake it, you can see it's still sort of liquidy, so gotta heat it, get rid of all the water. Until it's just the black powder, so it takes a little while. So the purpose of this lab is we want to figure out how many grams of copper oxide, which is the black powder, that we can make from 1 gram of copper carbonate hydroxide, which was the green powder. We're going to have to do some gram to gram stoichiometry. Your teacher may have given you a mole map, and we're going to learn how to use that, and then we're going to do a lot of gram to gram practice. It's a little bit more difficult than the mole to mole because we have to look up the molar mass of each one of these substances. Going to do it a little bit longer. So now as I shake it, it doesn't really have that liquidy feel, it just looks like powder, so I think it's done. So I'm going to turn my gas off, okay, and I'm going to put it in my test tube rack, and I'm going to let it cool. Then I'm going, after it cools, I'm going to measure the mass of just the test tube and this black powder. Alright, so I had, my final mass was 9.44 grams. And so when I subtracted 9.44 minus 8.76, I got 0.68. Okay, so I just did that by hand without using my calculator. So now we have to figure out how much CuO you should have made. So in order to do that, we have to figure out what the molar mass of CuO2, whenever we have grams, that means you have to figure out what the molar mass is by using our periodic table. Okay. And also for CuO, again, we need to figure out the molar mass. Alright, so Cu2, CO3, OH. So if I have Cu, that's 63.5 times 2, plus carbon is 12, plus 3 oxygens is 3 times 16, plus another 2 oxygens is 2 times 16, plus 2 hydrogens. And when I add that up, I can use my calculator, I get 221 grams. Alright, so that's molar mass of Cu2, CO3, OH2. Okay? Next, I'm going to do CuO, so that's 63.5 plus 16. So that's 79.5 is the molar mass. So I'm going to turn this over. Alright, so we have the molar mass of Cu2, CO3, OH2 as 221 grams, and the molar mass of CuO is 79.5 grams. From our balanced equation, our ratio of Cu2, CO3, OH2, we've got one of those for every 2 CuOs, so we need to know that too. So our mole ratio is 1 Cu2, CO3, OH2 to 2 CuO. Alright, so this is how we do this. I'm going to try to make sure that you can see this when I write it down. So we start with I had 1.1 grams. So 1.01 grams, 1.01 grams of CuO2, CO3OH2. So first of all, I need to convert that to moles. So there's in 1 mole of CuO2, there's 221 grams. Then, so this is the molar mass. And we're going to call this guy A. So this is the molar mass of A. Okay? Then we have to go from moles. We're trying to get to Cu2, okay? Grams of that. So then we have to go from moles of Cu2CO3 to moles of CuO. So in my equation, my ratio is 1 mole of Cu2CO3OH2 to 2 moles of CuO. Okay, so now I'm getting rid of this one, moles of this. And then finally, my molar mass in 1 mole, I've got 79.5 grams of CuO, and that's what I'm looking for, grams in 1 mole. So when I simplify that, that looks like a lot. That looks like a lot, but when I simplify that, the only numbers I really have to multiply are 2 times 79.5 divided by 221. And I'm going to end up with 0.72 grams of CuO. So in my experiment, I ended up with a little bit less than 0.72 grams. How could that be? Well, it's possible that I didn't get all of my 1.01 grams in there. So I might have started out with less than 1.01 grams. That's really the only explanation. Being off by 0.04 isn't a big deal. If you're higher than 0.72, that means that you probably did not heat it all the way and you had a lot of extra water in there still. If you're at 0.72 and you started with exactly 1.00 or 1.01, then you did a really good job. You followed the procedure. If you're about 0.73, 0.74, that's also really close. So that's it. That's this lab.